calculation versus conceptual questions? I can tell you that the one quarter of the class that has been marked with the tutors did not do one of the conceptual questions. But if I am marking it, I won't be very strict to the memo. So if you have an answer that's correct, whether it's my correct or your correct, that. But there will be a balance. There will be both. But I want to know which one to emphasize. So there's class exams, there's calculation. About the next topic. Would any of you like the proof pointer? Yes. No. If I give you a proof, you haven't seen it. Generalized coordinates and degrees of freedom. Yes. Like that. About solving a simple one-particle system using Lagrangian mechanics from beginning to end. The extent of mass, moment of inertia, calculation separately, as opposed to as part of the big problem. I'll ask you to calculate something. Give you the answer, so you get to this answer. And then I can change it to the question. I won't say calculate this and I'll use it to solve the problem. Right. The Lagrangian mechanics for systems. Like as in system of springs or something. something on the cosmic variation hash, symmetries, conservation laws, this new stuff. But what I will do is I will try to keep It's short questions. I won't make big long questions. And then I finally want to know the stuff that we're doing now, small oscillations, that has to come in. Again, it's the manner of how it comes in. So I could ask you one problem. And that one problem could involve solving Lagrangian mechanics in some way, one of these two. And then I could ask you to take your solution and apply this to it, the small oscillations. So I could do that, or I could give you a solved problem and tell you to apply small oscillations to that solved problem. Which one would you like? Would you like apply it to a problem you solve? Apply it to a solved problem. You have to do one or the other, guys. Okay, so that's the outline. I will now take a photo of the board and use it tonight. The exam will be out of 100 marks. You should attempt to do about 1.2 marks per minute. That's 1 mark, because 12 marks every 10 minutes.
The summary question I have how much will that be out of you mentioned 10 before.
The summary will definitely be there, and it will be out of summary out of my focus. It will definitely be out of 10 marks. Tomorrow I'll come back to you guys and I'll tell you how the cookie crumbled with the exam. Exactly what's in it. Right. It will probably be, look, it will probably be on a similar level to last year's exam. That's the one you must look at. Right. So don't compare it to your test, compare it to last year's exam. Make sure you can finish last year's exam. This test here was quite pressed for time to make sure that you feel it. To make sure that you know that you're going to have to work fast. You will have to work fast. It will be pressed for time. I can't promise that it will be as pressed for time as the test. Probably not. But you will be under time pressure. You will be under time pressure. You must work fast.
We didn't collect some points in class outside. What do we think?
Okay, so how the points work is if you've got 48% when you finish your mark, I'll find marks. And you'll get 50. And if you've got 73%, I'll find marks and you'll get 75. That's how the points work. So you get a class of special mark will suddenly appear. And it'll push you up to the boundary that you need to achieve. But if you get 45, I still can't push you that high. I can push you up to 47 or 48 in the hope that maybe that will help in average the other courses, but I can't make you pass if you're on 45. But if somebody who has gotten points in class is on a boundary of some important threshold, 1 or 2 marks away, the class participation mark will appear that it's enough to push them above that threshold. That's what's going to happen. So if you see your Lagrangian mechanics mark is 73, you come to me and say, hey, I have points. But most likely it won't be. Most likely I will have noticed that. It won't be. Yeah. Right. That pretty much concludes all of this stuff. The quiz is releasing itself tomorrow at 12:30. There's also a questionnaire releasing itself at that time. That's basically just asking you a couple of questions about how you found the structure of the course, things like oral tests, things like the very different style that this was done in order for me to improve in future. So it'd be nice if you answered that questionnaire, but of course it's not compulsory. It's up to you really what you want. Right, so let's just carry on with that small oscillation problem that we had. What we're going to do, we'll carry on with this problem now. I really want you guys to go through the past paper, the past exam. last year's exam. Because I think last year's exam is going to give you a very good idea about how it will work this year. Once you feel you have gone through it, we can go through it here together. We can discuss what points you didn't quite appreciate, what you enjoyed, what you struggled with. Should we do that tomorrow or should we do that on Monday? Monday. Right, Monday is the last class we have. So tomorrow, what I will do, you've all now got a chat book that you collected from the secretary's office. If you haven't, you can do that. That's been waiting there for a while. Today, when you go home, glance through this thing and find questions that you think look challenging, or that you can't quite figure out on your own. Tomorrow, we'll have a chat session where you come with this book and you say, all right, page 47, chat 24, what's going on? And then we can discuss it and go through it together. So tomorrow, the chat book. Monday, we'll discuss last year's exam, and also on Monday, I will talk to you about this year's exam. We've kind of designed it now, but I will talk to you about the kinds of things you should really focus on Monday. So I'll try to give you, like that talk we had before this test, that those of you who are sitting on a mark that is not 8% were present at, that talk will be beneficial. I had somebody who came to me to say people who did the oral test before the test had an unfair advantage in the test. How it's going to work for the exam, and my response at the time was, well, fine, the test only comes 2%. But then I thought about it and I thought, well, actually, all the important things for the test, even those that were in the oral test, I covered them in that lecture just before. No. I mentioned them. I talked about the sphere that you can show that the constraint is non-holonomic. I talked about all of those things. So, Monday. You should probably attend the exam. We will talk about the exam. I'll highlight important things. Try to point you in the right direction. So we were solving touch problem. You should all have touch books now. 30. More observations. Guy, and he had computed the two squiggle matrices, the T squiggle and the U squiggle. Can anybody tell me what they were? You got their notes on there. I don't get mine. So there will be conceptual questions on this section. Things like, what does a normal mode mean physically? And explain, therefore, what the normal modes of this problem are. We will certainly discuss that now. We will discuss, we'll go through the derivation of the normal modes and then we'll say what it means. Right. So, another thing, the oral tests, I didn't mention those. Obviously cannot mark all of them this week because some people still haven't handed them in. But I will try my very best to have everything I have available to me to marked by this Friday, by Monday. Let's hope that the marks are not what they were for the test. But I don't think so. On the whole, people have done well at the oral test. There are exceptions. There are the couple of very low marks. Those are people who handed me 2 pages of scribble. And the numbers like. But if you try hard, you won't fail. Even if you've written rubbish. If you try hard, you won't fail. Yes.
How do you mark them?
I mark the old test as follows. If you have not attempted a question, you get 0. If you have attempted the question, when I say not attempted now, I mean not that you haven't written down something, I mean that you haven't bothered to think. And it can be clear when someone's like, you write something here, that's normal. If you have attempted it but you really wrote rubbish, you're going down, you're barking up the absolutely wrong tree, 20% for that question. If you tried, and I can see you tried, but you're absolutely wrong, but you definitely gave it a shot, 40%. Partial marks meaning that you knew what you were doing, but you went severely wrong, 60%. Partial marks meaning you knew what you were doing and you made a stupid mistake, 80%. Correct? 100%. You went to the extra effort, you went the extra mile, you looked up something, you wrote something interesting, 120%. For every question I mark it like that. There are people who've gotten quite a few 120s in one test. Has happened. Of the tests that I've marked, the highest mark so far is 94. And I've only marked a very few, much less than a quarter. So there's hope when it comes to the oral test. Much more hope than there is with the test, seemingly. If you try hard, you will be rewarded for it. In the assignments, I tend to be a bit more strict. In the assignments, I tend to mark them, basically, if you have made a mistake, you don't get any gratis marks because you had a lot of time. So you then must have the correct answers. And I obviously give a lot of bonus marks away in the assignments. If you do something cool, bonus mark. If you do it correctly, of course. If you tried to do something cool and didn't get it right, you'll get maybe half a bonus mark. But if you have tried something interesting, you will get bonus marks in the assignment. Last year, the top mark I gave for the assignment was 138%. That person did a very excellent job. And she then took her work and published it in the Mathematica Journal. It was well received. So that's the level at which it was at. It was really, really brilliant. I don't just give you 120%. You can't be like, oh, I'm handing in an assignment, don't you? No. Like if it is, if you hand in an assignment and it's rubbish, it will be a mark that reflects that. But if you really do put in an effort and you go the extra mile, you will be rewarded. I'm not kidding here. If you do a good job and if you really try, you will be rewarded. I will not play around. I will give 20 bonus marks if I must, if I feel that you really, really did something. If you really thought about it, if you really tried, that you've been engaged in your assignment, I will reward you. If in your groups, if the assignment itself is worth, say, 70%, but I find an extremely brilliant job has been done on optimization, the person whose name is down for optimization will get 100%. Right, so, I mean, I will vary your marks from your group mark. Generally, not more than 5% below your group mark, but I can go very high above your group mark if I think something is exceptional. I will try to employ positive reinforcement. So, try to do a good job. You can get marks there. You can get a lot of marks in your assignment. Yes.
On the assignment, does presentation count much or is it functionality?
Look, by presentation, if you mean that you have made it look pretty, yeah, that's the point. But, I mean, it's more about the fact that you've done good work, and good work includes a good writer. If you have taken pains to write out your work and in a formal, correct, accurate, maybe even engaging fashion so that reading it is not difficult, I'll give marks to it. I mean, it means that you spend time thinking about laying out. I mean, I know, I'm writing some master thesis. You have to spend time sitting down and really thinking about someone reading this. If you just pour the facts out, like, all over the show, it can be difficult to appreciate what you've done. I will search, even if you've written it up in a rather haphazard fashion, I will search for work that has been done. I will search for places to give you marks, because it's much easier for me if you've written it out in a way that is clear, concise, to the point. I can tell you the distribution of marks on last year's assignment, but we've gotten kind of distracted, but I think it's important for you guys to know these things. In last year's assignment, the distribution of marks was something like the following. I mean, I'm saying numbers off the top of my head. I did email someone the correct numbers. Yeah. So I think very short assignments generally didn't do very well. Things less than 10 pages generally didn't do very well. They were generally low marks, with a couple of exceptions. There were people who got 100 and more with like a 12-page handout. Those are people who really thought about what they were writing. And they wrote such a brilliant piece of work, even though it was very short. It was so well laid out, and it covered all the important points. The mathematics was solved properly. There'd been investigations, physics, and it was a compact little document, 100%. 105, 110%. Then there's the reverse end of the spectrum. There were things handed into me of 80, 90 pages for which I gave 2%. They didn't bother to take the Wikipedia little thing at the bottom off when they pasted it. That's not cool. If I suspect your work is copied off the internet, I'll just start Googling passages out of it. And if I find it, then, you know, less than 5%. I'll give you 2% for your printing costs. Don't just copy off the internet, not a good plan, right? There's very nice software. You can even tell if you've taken something off the internet and changed the words around and put synonyms in some places. There's a nice plagiarism software that can cross-reference and do a web crawl and find that. So if I suspect foul play, I will search and then I will find you, and then you will be, you're lucky, I will just give you a low mark. And some lecturers would like discipline you and stuff. I will simply give you a mark below 5% for that. You're allowed to reference Wikipedia. Look, this is not a scholarly article, you're not putting it to a paper. If you have used Wikipedia, you can use an excellent reference. You're allowed to reference it. I mean, obviously you should then back up your stuff with other references. You can reference. As long as you don't copy from it, that's fine. And another thing, there were a lot of things that weren't plagiarized that didn't do too very well. There were things like 42, 45 pages long that didn't do particularly well because people hadn't thought about what they were doing. So that kind of pasted things in here and there, put in fixes, but not really thought about it. It was incoherent, it was a bit garbled. Those things didn't fail because, shame, someone has done 42 pages of original work and you failed and you're an original person. But they didn't do particularly well because it was not organized, it was incoherent, a lot of it was incorrect. I won't give very good marks for that. So, but then there were people, of course, who handed in that 138%, that was about 36, 37 pages of work. There were graphs inside, there were accompanying animations, there was a mathematical script that accompanied it. It was a lot of work, it was very, very high quality. Look, if you do that, if you do a very high quality piece of work, whether it's short or long, you'll get marks. You'll be rewarded. If you've thought about it, if you've really sat down and you've made sure your mathematics is correct, if you've made sure that your thought process is high quality, if you've been creative, if you've thrown in things here and there. For example, the spinning top project, if you first solved the spinning top, then done an animation of the spinning top, then tried changing some parameters, then tried changing the geometry, then a Fourier expansion, get into geometry, check what happens when it rolls, check what happens when it flips. When does it flip? Can I investigate when it flips? Find out stuff about when it flips. That's 100 and something. That's a very good project. It's hard to get there. So someone who's just simulated a spinning top will still pass. But, you know, the amount that you do, I've had a whole semester to think about it. So I'm hoping to see really good marks. I'm excited about what you guys are going to hand in. I'm hoping that will be very interesting. I've seen some really interesting work done by a lot of you already. You come to me, you've consulted with me. I've been surprised in a positive way by a lot of you when you get to consult with me, and I thought, let's see what they've been up to, and it's been very impressive. So I think I am optimistic about this. I think that you will do well at your assignment. You've got 10 minutes to quickly make some dent in this problem. So the next step in the algorithm here was to take this matrix, which is simply u tilde minus lambda t. Alright, so that's just very simple to write out. We've got 44 over 3L minus lambda g h lambda g, all times by m up. And the terms follow the same way. Not really and let's take u minus lambda g. So it's 8g minus 44 over 3 lambda L minus 6 lambda L minus 6 lambda L and 3g minus 4 lambda L. Right. That's not a particularly difficult story. Now we simply take the determinant of this and set it to 0, solve for the different lambdas. You know, the standard procedure for eigenvalues, these are generalized eigenvalues. Doesn't matter, it's the same thing. We go through the same steps. So the determinant of that matrix is equal to 8g minus 44 over 3 lambda L times by 3g minus 4 lambda L minus 56 lambda squared L squared. That's equal to 24 t squared plus 44 times 4 over 3. Calculator for 116 for 1676 again. Right, so this whole thing should be multiplied by ML. And I'm going to set it to 0, right? So I can cancel it. That's all it's there. So what's that? 176. Right. And we subtract 44 g lambda L, subtract another 8 4s, 32, that's 76. Let me know if I'm making arithmetic errors. Right. And now we have to try and factorize this lovely thing here.
Shouldn't it be x squared L squared because you took it out of the determinant?
This thing?
Yeah.
Yes, it should be, because it's both rows multiplied by n. And we still divide through, right? Yeah.
Should the 176 over 3 be positive?
Should the 176 over 3 be positive? It should. Okay, well observed. Right, so this is a lovely story to factorize. Anyone want to get the roots for us? Using the quadratic formula. Come on, you gotta calculate the quadratic formula pre-programmed into it. And divide